Strike a match. Watch the flame dance at your fingertips. You think you understand what you're seeing. You think fire burns things. You think it consumes, destroys, turns matter into ash and smoke. You've believed this since childhood, since the first time you sat around a campfire and watched wood disappear into glowing embers. But here's the truth that will shatter everything you thought you knew. Fire burns nothing. It never has, it never will. What you call burning is not destruction, it's transformation. It's one of the most elegant dances of atoms and energy in the entire universe. And once you understand what's really happening when something catches fire, you'll never look at a candle flame the same way again. I'm going to tell you something that sounds impossible. When you burn a log in your fireplace, the log doesn't disappear. Not a single atom of it vanishes. The carbon atoms that made up that tree are still here. The hydrogen, the oxygen, the trace minerals, all still present in this universe. Nothing was destroyed, nothing was consumed, nothing burned away into nothingness. So where did the log go? And if fire doesn't burn things, what does it actually do? The answer is beautiful, precise, and completely counterintuitive. And it begins with understanding something fundamental. Atoms are immortal. Let me take you back to a moment in your childhood. Maybe you were 6, 7 years old. You watched an adult strike a match, hold it to kindling, and within moments, flames spread across the wood. The wood turned black, crumbled, became ash. Eventually, nothing remained but gray powder and smoke drifting into the sky. Your child's mind made a simple conclusion. The fire ate the wood is gone now. It was destroyed. That conclusion was wrong. But it was reasonable. It matched what your eyes showed you. The wood was there, solid and heavy. Then fire touched it. Now the wood is gone. Cause and effect, destruction, burning. But your eyes lied to you. Or more precisely, your brain interpreted what your eyes saw using a framework that was too simple, too human scale, too blind to the atomic reality underneath. Here's what actually happened. And I want you to really think about this, because it's going to change how you see matter itself. Wood is made of molecules. Long chains of carbon, hydrogen, and oxygen atoms bonded together in complex arrangements we call cellulose, lignin, and other organic compounds. These molecules are stable. The atoms are happy where they are, locked into their current configuration by electromagnetic forces. But those atoms could be happier. They could be in a lower energy state if they rearrange themselves. Specifically, if the carbon atoms bonded with oxygen from the air to form carbon dioxide, and if the hydrogen atoms bonded with oxygen to form water vapor, the whole system would have less energy. It would be more stable. Think of it like a ball sitting on a hillside. The ball wants to roll downhill because that's a lower energy state, but there's a small bump in front of it. The ball is stuck. It needs a little push to get over that bump, and then gravity will do the rest. Fire is the push, heat is the push. When you strike a match, you're providing activation energy, just enough energy to break some of those initial chemical bonds and let the atoms start rearranging themselves. And once they start, the process releases energy, which breaks more bonds, which releases more energy in a cascading chain reaction we call combustion. But here's the crucial point. No atoms are destroyed in this process. Not one. Every carbon atom that was in the wood is still here. It's just bonded to oxygen now, floating away as carbon dioxide. Every hydrogen atom is still here, bonded to oxygen as water vapor in the smoke. Even the minerals and trace elements remain as ash. The total number of atoms before and after is exactly the same. The total mass is exactly the same. Nothing burned, nothing vanished. The atoms simply rearranged themselves into a more stable, lower energy configuration. Fire is not destruction. Fire is transformation. Now you might be thinking, okay, but something is clearly being consumed. The wood is gone. I can't burn it again. And you're right, the wood is gone. But not because atoms disappeared. Because the specific arrangement of atoms that we call wood has been transformed into a different arrangement that we call carbon dioxide, water vapor, and ash. It's like taking apart a Lego castle and rebuilding the bricks into a spaceship. The bricks still exist, but the castle is gone, not destroyed, reconfigured. This distinction might seem pedantic, but it's not. It's fundamental, because it reveals something profound about the nature of matter and energy, something that most people never truly grasp. Matter is conserved, always. In every chemical reaction, in every fire, in every transformation, the atoms persist. They're indestructible in any ordinary sense. You can rearrange them, but you cannot destroy them. The carbon atoms in the smoke rising from your campfire are the same carbon atoms that were once in the tree, that were once in the carbon dioxide the tree absorbed from the air, that were once in other plants and animals and bacteria stretching back billions of years. Those atoms are ancient, literally ancient. Every carbon atom in your body was forged in the heart of a dying star billions of years ago. When that star exploded in a supernova, it scattered those atoms across the cosmos. They drifted through space, condensed into new stars and planets, became part of Earth, cycled through countless organisms, and eventually became you. Fire doesn't burn those atoms. Fire can't burn those atoms. Fire merely liberates them from their current arrangement and allows them to join new arrangements. The atoms are eternal travelers, passing from form to form, structure to structure, never created, never destroyed, only endlessly recycled through the universe. This is the first law of thermodynamics. Energy cannot be created or destroyed, only transformed. And matter, at the chemical level, follows the same rule. Conservation is the deepest law we know. But there's more to this story, because while the atoms persist, something else is happening. Something is escaping. Something is radiating away into space, never to return. Energy. When wood burns, the chemical bonds holding the atoms together store potential energy. When those bonds break and new, more stable bonds form, the difference in energy has to go somewhere. It can't just vanish. Energy is conserved too. So it radiates away as heat and light. The warmth you feel from a fire, that's electromagnetic radiation, mostly in the infrared spectrum. The light you see, the dancing orange and yellow flames, that's radiation in the visible spectrum. The glow comes from tiny particles of soot heated to incandescence, emitting photons as they vibrate and transition between energy states. Every photon leaving that fire carries away a tiny bit of energy. Those photons fly outward at the speed of light, spreading through space, warming your hands, illuminating the darkness, and eventually escaping into the cosmos, never to return. This is where the mass goes, not the atoms stay. But mass and energy are equivalent, remember, Einstein taught us that. E equals mc squared. When energy leaves the system as light and heat, an equivalent amount of mass leaves too. Not as atoms flying away, but as pure energy radiating into space. If you could somehow capture all the smoke, all the ash, all the carbon dioxide, all the water vapor, every single atom that was in the original log, and weigh them precisely, you'd find they weigh slightly less than the original log. The difference is the mass energy that escaped as photons. The fire didn't burn the log. The fire transformed the log's chemical structure and radiated some of its binding energy into space. Let me make this viscerally real for you. Tonight, go outside and light a candle. Watch the flame. Really watch it. That flame is not touching the wax. The wax doesn't burn directly. Instead, the heat from the flame melts the wax, which travels up the wick by capillary action. At the top of the wick, the liquid wax vaporizes into gas. That gas, a mixture of hydrocarbons, mixes with oxygen in the air. The heat provides activation energy. The molecules break apart and recombine. Carbon atoms bond with oxygen to form carbon dioxide. Hydrogen atoms bond with oxygen to form water vapor. The reaction releases energy which heats nearby molecules, causing them to react, creating a self-sustaining chain reaction. The heat also excites electrons in the atoms, causing them to jump to higher energy states. When they fall back down, they emit photons, light. The yellow glow of the flame comes from tiny particles of carbon soot heated to around 1,800 Kelvin. At that temperature, they emit blackbody radiation primarily in the yellow-orange part of the spectrum. The blue base of the flame comes from a different chemical reaction, where carbon monoxide is still burning, emitting light at shorter wavelengths. None of this is destruction, it's all transformation. Rearrangement. Energy flowing from high-density storage and chemical bonds to dispersed radiation spreading through space. And here's something that will bend your mind. The candle flame is not a thing. It's a process. It has no substance. It's a region of space where chemical reactions are happening rapidly enough to heat the surrounding gas and cause it to glow. The flame has no physical existence separate from those reactions. Stop the reactions, and the flame instantly ceases to exist. It's not made of anything. It's not an object. It's an event. You cannot hold fire in your hand because there's nothing to hold. Fire is not matter. Fire is matter transforming. This understanding, this deep recognition that burning is transformation rather than destruction, connects to something even more profound. It connects to the story of everything. You see, the universe has been burning since the beginning, not with chemical fire, but with nuclear fire. Stars are burning right now, fusing hydrogen into helium, helium into carbon, carbon into heavier elements, all the way up to iron. But again, burning is the wrong word. Stars aren't consuming hydrogen, they're transforming it. In the core of the sun, every second, 600 million tons of hydrogen are transformed into helium. But only 596 million tons of helium emerge. The missing 4 million tons, converted into pure energy via Einstein's equation. That energy radiates outward as light and heat, taking 8 minutes to reach Earth, warming our planet, driving photosynthesis, creating weather, enabling life. The sun is not burning. The sun is transforming matter into energy through nuclear fusion. And like chemical combustion, nothing is destroyed. The atoms are rearranged. Energy is released. Conservation laws hold. When that same sunlight strikes a leaf, photosynthesis reverses the process. Carbon dioxide and water are transformed into glucose and oxygen, storing solar energy in chemical bonds. When you eat that plant, or eat an animal that ate that plant, your cells break those bonds, releasing the stored energy to power your metabolism, your thoughts, your heartbeat. You are a temporary eddy in the great flow of matter and energy through the universe. The atoms that make up your body right now were once in other bodies, other structures, other forms. They cycled through fires and stars and oceans and clouds and soil. They'll continue cycling long after you're gone. Nothing is permanent except the atoms themselves and the laws that govern their interactions. Everything else, every structure, every pattern, every living thing is temporary. We are all flames, burning brightly for a moment, then dispersing back into the cosmic flow. But unlike a candle flame, we are conscious. We can understand our own impermanence. We can trace the atoms in our bodies back to their stellar origins. We can light fires and comprehend at a molecular level exactly what we're doing and why it works. That's extraordinary. That's a privilege no other species on Earth possesses. We are matter that has become aware of itself, capable of understanding transformation, conservation, and the deep structure of reality. So let's return to where we started. You strike a match. The flame appears. What's really happening? You're providing activation energy to break molecular bonds in the match head. Those molecules react with oxygen, releasing energy, which heats nearby molecules, creating a chain reaction. The wood of the match undergoes the same process. Carbon atoms bond with oxygen, forming carbon dioxide. Hydrogen atoms bond with oxygen, forming water vapor. Energy radiates away as heat and light. The solid structure of the match is transformed into gas and ash, but not a single atom is destroyed. Not one carbon nucleus ceases to exist. Not one hydrogen atom vanishes. They persist, they transform, they move on to their next arrangement. The match didn't burn, it transformed, and so does everything else. When you burn gasoline in your car, you're transforming hydrocarbons and oxygen into carbon dioxide and water, releasing energy to push pistons and move your vehicle. When your body metabolizes food, you're transforming glucose and oxygen into carbon dioxide and water, releasing energy to power your cells. When a forest fire rages, it's transforming trees and oxygen into smoke and ash, releasing energy that was stored by photosynthesis over decades. All of these are the same process at different scales. Chemical bonds breaking and forming, energy being released or absorbed, atoms rearranging. Nothing burning, nothing destroyed, only transformation. This is why conservation laws are so powerful in physics. They tell us what cannot happen. You cannot destroy matter in a chemical reaction. You cannot destroy energy. You can only move things around, transform one form into another, redistribute the pieces on the board. And this constraint, this fundamental limitation, is what makes the universe comprehensible. If atoms could simply pop into and out of existence randomly, if energy could appear from nowhere and vanish to nowhere, we could never understand anything. Science would be impossible. But because conservation laws hold, because transformation follows rules, we can trace causes and effects, we can predict, we can understand. Fire doesn't burn. And understanding that it doesn't, understanding what it actually does, opens a window into the deepest truths about matter, energy, and existence itself. I want you to think about what this means for how we use language, how we conceptualize the world. We say burning and destruction and consumption because those words capture our human scale experience. The log disappears from view, the match is gone. For practical purposes, we destroyed them. But at the fundamental level, we didn't. We rearranged, we transformed, we redistributed. And recognizing this distinction matters because it reveals the difference between appearance and reality, between useful metaphor and actual mechanism. Science is full of these moments where everyday language betrays us. We say the sun rises when it's actually the earth rotating. We say objects fall when they're actually following the curvature of space-time. We say fire burns when it's actually transforming chemical structures and releasing energy. Language evolved to help us survive and communicate, not to describe the universe accurately. So when we do science, we have to be careful. We have to look past the convenient metaphors to the precise mechanisms underneath. We have to ask, what is actually happening, not what does it look like? Not what's the useful way to think about it, but what is literally, physically occurring at the level of atoms and energy. That's the difference between engineering and physics. Engineering can work with useful approximations, but physics demands truth. And the truth about fire is that it doesn't burn anything. One more thing. And this is where it gets personal. You are burning right now, not with flame, but with the same chemical process. Every cell in your body is undergoing controlled combustion, breaking down glucose, combining it with oxygen, producing energy. You are a slow fire. A cold fire maintaining itself at 37 degrees Celsius instead of 1,000 degrees. But it's the same chemistry, the same transformation. When you die, that fire goes out. The atoms that made you up begin their next journey dispersing into soil, absorbed by bacteria and fungi and plants. You will become other things, other structures, but your atoms will persist. They cannot be destroyed. They can only transform eternally. This isn't mysticism. This is literal fact. You are made of stardust. You are a temporary arrangement of ancient atoms. You are a flame that knows it's a flame. Understanding that changes everything. It makes death less frightening because you can't truly disappear. It makes life more precious because you recognize how improbable this arrangement is. It connects you to everything else you're made of, the same stuff, following the same laws, participating in the same cosmic dance. Fire doesn't burn, it transforms, and so do you. That's the real miracle. Not that fire burns, because it doesn't, but that we can know what it actually does and why. Fire burns nothing, but it illuminates everything.